The equation of a linear function q and a table of a linear function r, so two different linear functions are shown. Which statement correctly compares the slopes and y-intercepts of the two functions? If you hear that whining, it's just my doggy. Hi, doggy. Whining at my kitty. Hi, kitty. See, this is how we do. Okay. So no animals are being harmed in the making of this video, unless they harm each other. Okay, so we have q of x. Yes, that's how I write a q. And then we have our table over here. This is in y equals mx plus b form, our favorite form. So our slope is going to be a 2, and our y-intercept is going to be the -1. Okay? Looking at our answer choices before we do anything else. Function r has a lesser y-intercept and a slope that's 2 times 3 times. Okay. So we got to compare them. All right, so let's look at our chart here, and we want to figure out a formula for these. I immediately notice my y-intercept is going to be 0, -2. Okay, if we have this graphically, 0, -2 is our first point, and that is on the y-axis. That is our y-intercept. So if we're looking at y equals mx plus b, my b is going to be that -2. Now we have to figure out what our slope would be. So plotting 1, 4, 1, 2, 3, 4. We can count this out, rise over run to find our slope. 1, 2, 3, 4, 5, 6. A rise of 6. And my run is 1. That means my slope is just that 6 over 1 or 6. You could also, if you wanted to, use slope equals y2 minus y1 over x2 minus x1. You're going to get the same result. Okay, so if you want to use the equation, that's fine. I prefer to graph things. So slope 2, over here we have a slope 6, y-intercept -1, y-intercept -2. And that sound is the dog chewing on my chair. So let's look at our answers. Function r has a lesser y-intercept. Is that true? That is true. Y-intercept 1, -1, -2. And a slope that is 3 times the slope of q. That is true. 6 is 3 times 2. So it looks like B is going to be our answer.